right, folks, it's Bass Action back in action here. In this video, we're going to go through some examples on triangle area and specifically working with 30, 60, 90 triangles. All right, so let's take a look here. First at our instructions, exact methods. Remember, that means no decimals anywhere in our work or our final answer. These problems want us to find the exact area and perimeter of each triangle. So taking a look at our first one here, it's a right triangle. So in order to use the area, we are going to need the two legs of this triangle. We can see it's a 30, 60, 90 triangle, and the piece that was given to us is the short leg. Okay, remember the short leg is going to be across from the 30 degrees. We can also write down our extended ratio, our 1, 2, radical 3, to help us remember how to move back and forth. So if I have the short and I want the hypotenuse, that's the 2, I'm going to go from here to here. I'm going to multiply. So that's going to fill in an 8 radical 3 on the hypotenuse. To go from the short to the long, I'm going to multiply by a radical 3. So I'm going to have a 4 radical 3 times a radical 3. So I'm going to have a 4 radical 3 times a radical 3. That means I'm going to have 4 times 3, or a 12. Okay, so the area of this triangle is going to be 1/2, and I can do the product of the legs, 12 times 4 radical 3. So that means I'm going to have really a 6 times a 4. So I'm going to have a 24 radical 3, and we want to label that units squared. Next, we're going to do the perimeter. Now, we want to be careful when we are doing perimeter to only add our like terms. So the 8 radical 3 and the 4 radical 3 are going to be the like terms. So we'll have a 12 radical 3 plus that other 12, and we can label this answer as units. Okay, so that's just a really quick, simple, basic one. Now, this triangle is equilateral, and you'll notice I've given you the side of the equilateral triangle. There are many ways to do the area of an equilateral triangle. I think the easiest is to draw in this nice height, and then this will look like our proof from the previous page. So that's going to be 60 degrees. If we've got this 12, this side was 12, and of course this is going to become half. That's now going to give us the short. If we know the short, we can now get the height, which is going to be the long in this case. So we're going short to long, multiply by radical 3. So that's going to give us a 6 radical 3 for the height. Now the area is going to be this height times this entire side. That's a common mistake that students make. So we're going to have for our area 1/2, our height 6 radical 3, and our entire base of 12. So I like to do 6. Half of the 6 is 3. 3 times 12 is going to be a 36. So we're going to have a 36 radical 3, again, units squared. Our perimeter, that one's going to be easy peasy because the side and the triangle is just 12. So we're just doing 12 times 3, or 36. So 36 units there. Okay. Next, let's look at 2 more scenarios with an equilateral triangle where I give you something different. Okay. So on our next equilateral triangle, I've given you this little piece. In geometry, you would have called this the apothem or the apothem, depending who you had. There's a couple ways that we can do this problem. We can extend this and turn this into a height. And if we do that, what we need to remember is that this length and this length are not the same, because this one is a radius. It's like connecting all the way out here. But thinking back to geometry, depending which level geometry you took, the length of the apothem is going to be half of this piece right here. So this would become 24 up here. Now, the other way that we can also get that 24 is to imagine this little radius here. A couple ways we can get there. If that little piece is 12 and we draw in the radius and this is 30, I have a little 30, 60, 90 triangle here, and this 12 is the short which makes this piece right here the long. So this is going to become 12 radical 3. Now, ladies and gentlemen, this is probably the fastest way to do this problem, but it might not be the easiest for you. You can get to this side out here being 24 radical 3 by working with this whole height right here of 36. You can choose, but I'm going to go with this fast way because I like it. And now I've got my height and I have the side of my triangle. So my area is going to be 1/2. My base is now 24 radical 3. And my height of my triangle is 36. So now, when I multiply again, 1/2 times 24 is going to be 12. And then my 12 times my 36 is going to give me 432. And it's okay if you busted out a calculator for that part. 432 radical 3 units squared. The perimeter is going to be 3 times the 24 radical 3. And our 3 times our 24 radical 3 is going to give us a nice 72 radical 3 units. Definitely get in the habit of labeling these. The last one that we're going to do is going to have this little radius here of a 12. So you'll notice that now I've given you this piece that I drew in right here. So what I'm going to do is I'm going to finish off that little tiny triangle. I also do like to extend this up here because this piece up here would be a 12 as well. And this 12 is now the hypotenuse in a little 30, 60, 90 triangle. Remember, this is going to be 30 degrees. So that makes this piece 6. Notice again, this piece is half of that, just like it was back here. Now, I have the short leg in this little 30, 60, 90 triangle, which makes the long leg in that little one 6 radical 3, which makes this 6 radical 3, which means I can now do the height and the base. So the area of my triangle is 1/2 12 radical 3 times that height there of an 18. So I'm going to have a 1/2 times my 12 is 6, and then my 6 times my 18 is going to give me a 108 radical 3 units squared. The perimeter of this triangle is going to be 3, and the side is 12 radical 3. So it's going to be 36 radical 3 units, because I don't know what these are all labeled in. Okay, so that's our area and our perimeter and working with our equilateral triangles, which is a really, really important skill for you to have.